Okay, I think we're set to go. Looks like we got some last minute stragglers coming in, but we'll go ahead and get started for everybody. Hopefully you guys can see my screen and see me and Sam, the presenters for this webinar, but I just wanted to say welcome to this edition of a SkyCiv webinar. This is the 22 shortcuts, tips, and tricks in structural 3D. For all of our veterans out there, hopefully you find at least a couple of things useful in here that you can take back for your practice, and everybody else who's fairly new to the platform, hopefully you can take a bunch and help yourself model faster and just work better. So with that, let's just get started, and we'll make sure to have the stragglers come in as they go. So just a little bit about the agenda. We're going to talk a little bit about just the presenters, being Sam and I. A little kind of intro about SkyCiv, a little bit about a history, a little bit about what's available on the platform. But the majority of the time will be spent Sam actually demoing these 22 tips and tricks. So, and then at the end, we'll do a little question and answer. So just as a reminder, make sure to chuck as many questions as you have in the question and answer prompt or box or whatever you guys have on your screen, and we'll be happy to address as many as we possibly can at the end of the webinar. So let's just jump right in. A little bit about us. My name is Trevor Soley. I am a sales onboarding and support manager here at SkyCiv, and I do most of that in Northern America, but I also obviously support other regions around the world as well. So I'm sure I've helped or communicated with at least a few of you online here. My past experience has been with a architectural engineering firm, and then previously before that I was a project engineer for a general contractor. So a little bit of a variety of experience, and then I just wanted to put on there that my goal is to try and help brainstorm solutions to certain engineering problems and figure out the best way to solve those things with our platform with engineers. So I'll just let Sam introduce himself quickly, and then we'll keep going.
Yeah, thanks, Trevor. So yeah, my name is Sam. I'm one of the co-founders here at SkyCiv and one of the original developers on Structural 3D. So really excited to take you through some of these tips and tricks. Personally involved with a lot of them, and it's really going to be a fun webinar to uncover a lot of those. But yeah, as Trevor mentioned as well, also helping out on customer support and quite involved in the users' journey as well. So I've spoken to a lot of the people online today, so nice to see you all joining. And for those who haven't met me before, yeah, my name is Sam, and look forward to taking you through this webinar today. Thanks, Trevor.
Yeah, no, awesome. Looking forward to going through those tips, and just as a forewarning or comment, we will be recording this webinar and posting it on our various mediums. So you'll be able to reference any of these tools and tips and tricks. So yeah. So I wanted to put this in the intro here just to kind of highlight a few things. This is our kind of our milestone history here, starting all the way back in 2013 when Sam and his co-founder Paul just kind of created this fun tool called bendingmomentdiagram.com. And I'm not sure if any of you have actually been with us that long, but since that year, we've been steadily growing, steadily increasing the number of users we have, the number of solves that have been run on our software, as well as just the number of features. The more robust the software has become. And really what I'm trying to get at here is if you look at the history of our platform, you can just see how steadily we've been adding to it, and how we're not complacent in not adding new features or not talking to users and figuring out what they need and what they want most. And then we're not going to rest on our laurels and just kind of be complacent in adding new features. So hopefully that gives you a little bit of a added trust element to what you think about our platform. But like I said, the history, while relatively short to other legacy options in the industry, we're very active, and we really enjoy adding to this timeline as we go. So yeah, and you can find this on our About Us page too if you want to read more. The last thing I'll go over just quickly before Sam gets into the bulk of the webinar, obviously you don't want to waste too much of your guys' time, but just wanted to lay out kind of a short list of all of the stuff that we have as a professional user, you would be able to access. So analysis tools, design tools, and then other kind of little tidbits and other products as well. So just wanted to point this out so that if you, as a user now or professional user, whatever your case may be, if you're only taking advantage of a couple of these things and you didn't necessarily know that any of the other things were available, or they were not online yet, this is what we have so far. And again, we're constantly adding to it. So again, just a quick short list of things that you can pick out if you don't actually if you didn't know that it was available at that time. So yeah, that's just, again, really quick intro. Wanted to just talk about the history and a little bit about what's available with us. And without further ado, I'd like to hand it over to Sam, and he'll jump right into those tools and tricks. And one last reminder, just make sure to put those questions in the answer box, and we're happy to address those at the end of the webinar.
Yeah, thanks, Trevor. Just taking over now. Okay, so yeah, really excited to take everyone through this. I think it's been a long time coming. There's quite a lot of features and functionality packed into S3D, and because we try to keep the interface really intuitive and easy to learn, sometimes those tips and tricks are a little bit difficult to uncover. So we're really excited to shed the spotlight on them today, and really go through a lot of the ones that we find internally really helpful when we're modeling structures, and some of the feedback that we've gotten off users, and really focus on those 22. Just before we jump into it, I wanted to share this recent survey that we ran along with a built-up organization that kind of interviewed a lot of, I think it was over 400 structural engineers, asking them how long it takes to learn typical structural analysis software, and using it, that's kind of that black bar graph. And the weighted average, it came out to be about 4 or 5 months for traditional software. And we ran an internal survey, and SkyCiv users voted that on average it takes less than a week. So that was really exciting to see, just because the company was kind of founded on the basis of creating easy, intuitive, and online software. So really excited to see those sorts of results come back. So I just wanted to also thank those people who participated in the survey as well. And it was really great to see that. So I thought I'd just share that recent survey that came through. But without any further ado, let's jump into the actual software and take you through the 22 tips. So we're going to build something similar to this structure. So sort of like a monoslope structure. And we're going to start with a clean slate and build using the 22 tips in the slideshow that I've got. Just worth mentioning that these tips are available under this tab here, so S3D shortcuts and tips. So we're always adding more features into the software, and when we do, we add them into this page as well. So you can see a lot of the tips that I'm covering today, but also a lot of other ones that are really helpful. So feel free to check that out at any time and refer back to that in case you forget any of these or we add any more as well. So let's jump ahead into our first tip. So we're going to go into the pen tool, including snapping and midpoint. So pen tools access through this right menu here just by clicking the pen and just toggling on the pen tool. And some people might be already familiar with it, but in case you're not, let's go through it. And you can just click anywhere on the canvas, and that'll plot the first node at the origin 0, 0, 0. So from there, I can trace along the x-axis or trace along the z-axis, so any of the xyz coordinates, and it'll anticipate my action there. So this is kind of inspired based on a Google Drawings product that we use quite a lot and we really enjoyed. It just made mocking up simple drawings really easy. So it's kind of drawn off a little bit of that inspiration from there, and you can sort of move around, zooming in and out, and just quickly mock up sort of, parts of your model, parts of your frame. And it'll also pick up adjacent nodes. So you can see if I'm hovering past that one, it's going to pick up that there is a node there 5 feet down. So it makes sort of, mocking up your models or your frames really easy because it's already picking up those points of interest, ready to sort of connect as you need. So keep building up. And one tip is I like to really have my finger hovering over the escape key. And why that helps is, so see how it's already automatically connecting. From here, maybe I don't want to connect anymore. I just hit escape and I can start again, mapping my my new nodes. So yeah, and other things that it can do is sort of, if I come up here, I can also snap to other members. So if I want to connect that node to member 4, I can hover along the member and it's going to pick that up. And I can also even pick up the midpoint there on node 4. So it's just kind of fighting with the x-axis there, but there I can pick up points of interest like the midpoint of certain members and connect to those as well. Yeah, so I'll just undo those changes, go back to the default tool, and that is our first tip of the day. Next is box highlighting. So click and drag, so you can hold Control and then click and drag to select parts of the model. So if I go right to left, that's going to highlight anything that's explicitly within that blue box. So you can see it's only picking up the nodes and members that are 100% in that box. Whereas if I go left, hold Control and click and drag left to right, that'll highlight anything that comes in contact with that blue box. So you can see now members 4 and 8 are getting picked up. So if I do something like that, it'll highlight. So it's really worth knowing those different operations, because if you want to select these 2 members, that's really easy. Or if you want to select sort of whole parts of the structure, that's really easy as well. So just being able to toggle between those 2 options by either going left to right or right to left is really, really handy. Right click, add bracing. So we've got quite a lot of right click functionality that we'll cover today. First one is bracing. So to do bracing, to add bracing, just highlight any 4 nodes. So I'm just going to highlight them like using the box highlight, right click and add bracing. So it doesn't matter that I was highlighting the members as well, as long as I'm highlighting at least 4 nodes, 4 nodes exactly for bracing, it'll detect that I can add bracing there. So that's just a nice and easy way to add bracing. You can do it in any plane, even if it's diagonal. So feel free to make the most of that one. That's a nice and easy right-click functionality. Double click input fields to import selected nodes. Now that's a bit hard to explain with words, but it's probably easy to show if I show you. So what we tried to do is incorporate as much of the graphics as possible. We know that's the easiest way to identify parts of your model that you want to add. So for instance, if we want to add in the supports at the base, I'll just box highlight all the nodes. And if I click supports, normally I could type in 1, 2, 3, 4, or the node IDs there. But if I've got them highlighted here on the right, I can just double click and it'll paste the node IDs from the graphics into the input and hit enter. So that's just a really easy way to sort of select the part of the model that you want to assign, add loads to or supports or anything like that. It's just a really quick and easy way. And that works for basically anything. So if I want to add, say, loads to the top, I can highlight all these members and I go distribute loads. I can, again, double click here, or I can just use this button here. I'll do the same thing. And if I just tap through, tap and enter, I can add quickly add loads in mass to parts of the model just by selecting them and then double clicking them. So anywhere where you see this box like this little downward arrow, I can double click to paste from the graphics in. So I'll just undo that. But yeah, that works with anything, loads, plates, supports. So it's a really handy function to know. Tip number 5 is Control A to select all and Control D to duplicate. So I've got a sort of a substructure here, and I might want to replicate this out, a number of times. What I can do is just Control A and then Control D. And here's my number of repetition, going across in the X, and we're going to go the positive X direction by 8 feet. And this will take along with it any supports or any loads I have to it, and carry them through as well. So if I've already spent the time to add loads and load groups and things like that, it'll bring them along with it. And just a quick shortcut, the reason I knew it was 8 was I hovered over this member and the bottom left corner showed me the length of that member. So I can even click it if I want to sort of get an idea of how far I had to duplicate the length there. So this bottom bar is quite handy for information like that, and even hovering over nodes to get those coordinates. Just really useful to sort of get my bearings about the model. So pressing R for relative members. So this is quite a hidden feature, but it's quite useful. So it just helps me sort of add members and nodes from a reference point that might not be the global origin. So I'll just start by highlighting these two nodes, 2 and 5, and then I'm just going to press the R key, and this will open up a really convenient and easy box that allows me to add members relative to those nodes that we've just added. So you can see it's got a helpful tooltip, but it basically I've put in how far along the x-axis I want to go, so maybe like 20 feet, and how far up I want to go, so say 5 feet up in the y. And you can see it's sort of showing a trajectory of where that member is going to go. So that's really helpful if I'm just trying to get, you know, the distance right or something right. But it definitely helps with not having to get the global coordinates if I've got some reference point, especially if you've got some really, you know, trailing fractions and things like that. And you can also do it in different planes as well. So we've got X, Y, XZ, and ZY. So we'll do an XY trajectory. And this one is even easier because it goes further to where you can just add an angle and a length. So say it's a 12-degree pitch at, say, 40 feet or something like that. You can see how that can quickly and easily traject that line that you're looking for without having to calculate the trigonometry of those these points here. And I've done that because I highlighted both. It's done it on the two nodes, and that's done all the maths for me just to easily get in a direction there. So that's relative members. So tip number 7 is just an extension of the pen tool. So I'm going to open up this pen tool again. You see I probably refer to the pen tool quite a few times just because it's a quick and easy way to model. But not only does the pen tool sort of pick up X, Y, and Z, but if there is an angled member attached to this node 22, it'll also detect that and allow you to sort of extend those members out. So this is really helpful if you've got like roofs and things like that angled or inclined members. It just helps you sort of get those, add to those without having to work out the trig again. Another quick shortcut is this is moving by increments of 0.1 feet. But if I needed to do something a little bit more specific, I could just simply, as I've got that highlighted, I could type in, say, 8.25, and that'll give me that specific distance, and can just hit enter, and that'll add that for me. So now I've got a member of 8.25. So just typing while having the pen tool connected is a great way to get exact dimensions if you need to. Again, I'll undo that just by hitting Control Z, and yeah, we can continue through. So holding number to add that section ID. So as I've got my default tool open, I can click and drag between nodes to connect them. And one quick shortcut is if I hold the number 2, for instance, and while I'm doing this, it'll add another section 2. And you can see that's gone green. So it's just a really quick and easy way to identify and sort of model up parts of your structure. So maybe when I'm doing bracing, I want to introduce another section. I'll hold 3 as I'm connecting those. And you can see I've added another section ID there. So you can sort of start to assign these members with section IDs as you're modeling rather than do them in 2 discrete steps. And that's tip number 8. So tip number 9 is spanning members. So it's another right-click function. And the way that one works is if I select 2, so I'm just going to hold Control and select 2 members, right-click, and there'll be a span members option there. Oops, hit the wrong one. Sorry, span members. And you just have to enter how many spacings you want. So I'll say 4. And this will just automatically add in those members in between members 7 and 11 in this example. So just a really easy way to sort of add things like this, like rafters or joists, and not having to worry about splitting this member and adding nodes. You can just simply highlight 2 members and span them. Tip number 10 is adding sections quickly using the search functionality. So here we've got 3 sections, but they haven't been defined yet, so they're just vectors in space, really. So we need to assign some properties, some section properties to those. And I just find using the quick search button is a really handy way to quickly add in, some sort of sections, and especially if you roughly know what you're looking for, just search the database. Maybe we'll add some HSS, and pick up sort of sections that you're wanting to assign. So in a matter of seconds, you can quickly assign what these 3 sections are. And you don't have to just search. You can also just go through, say, the database, look for sort of equal angles and scroll through and have a quick look at what's in the library. Still takes just a few seconds to assign those. So now we have some columns, some HSS, and some angles. Another tip, quite helpful, is just turning on the 3D members here. So it gives you a rough idea, just kind of what you're looking at without having to go into the renderer, and you can just sort of see we've got some angles here, we've got some I-beams, and just get a feel for what your the dimensions of your sections are. So it's a little handy tip there. And that's adding sections through quick search. Multi-editing is probably one of the most useful features when you're trying to make adjustments to your model in mass. So we'll use this a couple of times, but what it basically entails is highlighting parts of your model. So say those members, we want to change all those members section IDs, for instance. So I'll highlight the members and then I'll hit members, and it'll automatically pick up that I've got a number of members highlighted. I've got all these IDs highlighted, and I can just change that to HSS, for instance. And I'll just turn this off to save it confirming each time. So you see quite quickly, you're able to change things in mass. And this works not only for members, but you can do plates, loads, supports, nodes, whatever you want. So even in this example, if I click now nodes, because I want to change all the nodes, it'll detect that they all sit at the same Y coordinate, but maybe we want to change that to 7, and that will then move all those nodes for me in one hit. So that's a really handy feature. I'll just undo that, make a few more adjustments to the model. And another quick shortcut, not in the tips, but it's really, really handy, is just hiding parts of the structure. So just going to hide that just to make this a little bit easier while I'm changing these bracing members. Again, using the box highlight combined with the multi-edit to change that to being these equal angles that I entered in earlier. There you go. So yeah, hiding is quite useful for things like that. And then I can just right-click Show All to bring back the rest of my structure. So that is multi-editing. Tip number 12 is auto-grouping. So as structural engineers, when we're typically looking at structure, we're not looking at them as individual members. We're usually treating them as sort of similar members. So we've got some sort of columns, we have some beams, we have some bracing, and we generally classify them into those groups, and then sort of just base our designs on those. So the auto-grouping functionality is meant to assist with that. So the way you can access that is through advanced groups, or just by hitting Control G. And we're going to focus on the auto grouping function, which is basically an algorithm that runs through your model, scans through and detects all the similar members. And so I'm just going to run that, and I'm going to group by material, direction, and section, sorry. And what that will do is pick up these similar members here. So we've got some columns, we've got some beams going in the X direction, sorry. We've got some beams going to Z. We've got our joists there, And then we've got some bracing. So it's also smart enough to detect that these are in opposite but equal directions. They should be treated the same. And we can just go through and even rename these to make it a bit easier. I'll leave that one. I'll put this afters. And you can see these two are fairly similar. So I'm just going to hold Shift and highlight and click those two and just merge them as being a single group. So yeah, they can be sort of treated as one. So I'll just merge those groups. And where this is handy, grouping is quite helpful in the modeling stage, but also in the analysis and the design stage. But for modeling, it really helps if I say I want to edit all those similar members at one stage. I can just hit the edit button and it'll bring me back to multi-edit, and I can change this to say, even introduce a new section ID, section ID 4. That's just a real quick and easy way to yeah, sort of add in or edit parts of your structure just based on the groups that they're in. So that is auto grouping. That'll come up a little bit later in the post-processing tips. I'm going to switch gears a little bit and go to the section builder. So section builder has quite a lot of features packed into it, but we're just going to look at a couple for the purposes of this webinar. One of which is just toggling off this clear others box and allowing you to add in other shapes. This is particularly handy for composites or built up shapes. So say we want to do something like this, and then we can sort of just click and drag to move it into position. And yeah, quite easy to sort of use the graphics and some of these features to create custom shapes and built up shapes. Also got the importing of the DXF files and line shapes. So that's some functionality that I know is helping a lot of users. But for now, I'll exit without saving. We'll just stick to sort of, for the purposes of this webinar, database shapes. So yeah, that's number 13. Number 14 is intersecting members. Now this one is extremely useful for all sorts of things, but in this example, if I want to connect this column up to support these rafters, I'm just going to use the pen tool again just to plot some members through, oops, Control Z there. And it doesn't really matter where I go for that, but yeah, go back to the default tool. So here I've got a column passing through a rafter, but they're not connected because there's no node there. So what I'm going to use is the right-click Intersect Members, and that will automatically connect and split those members into two. And I can do this in mass too, so I could highlight these two and just do that in one step. And you can see it's made those splits. And I'll just delete those members. So that's just a really quick and easy way to connect my columns to, you know, especially inclined members without having to calculate where that node location is. So just by using the intersect functionality. And just on that note, you can access that as well through split members. So splitting members, you can split your member into equal parts by percentage, by intersecting members, or by intersecting nodes. So you can sort of open up some additional functionality through split members. But that is intersecting members. Right-click join member, again, another right-click function. So right now I've got this split into two from the intersecting function, but if I want to reconnect them as a continuous member, I can just highlight those two members. And because they're in line, this option join members will display for me. So that will just connect it all as one continuous member. It saves me deleting those two and adding a member manually. I can also hit Control J, it's a shortcut. And just on that note, the right-click functionality is built, it's a dynamic menu. So basically, it will only display the functions that are available to clicking that particular element. So for instance, you can see here, join member is not an option. But if I click these two, which are in parallel or in line, join option will become available. So the reason that's incorporated is just to make the right-click menu quite concise and easy to find what you're looking for, because you're only showing the options that are available to you. it just saves us really showing a really long and overly detailed right-click menu by really just tailoring that right-click to what you've actually clicked. So that's just a little side note. So sometimes you might find there's certain functions not visible, but if you select the right number of elements or the right type of elements, it will show for you. So tip 16, shifting nodes. So shifting nodes, I'll just connect this one here too. Let's put a beam here. Shifting nodes, there's a couple of ways to do this. I can go advanced, edit operations, shift nodes, or I can again just right click. It's detected I've selected a bunch of nodes, so shift nodes. And say we want to move this up 3 feet, and I'm just going to click that box on to explain what this connected nodes functionality does. So what I've done is I've moved those nodes up, and what the software does is it actually detects any connected nodes. So in this example, I've got member 7 here that passes through node 31, and it's detected that, and it's moved node 31 with it, because we know, when we're adjusting models, sometimes it's really complex and kind of annoying task, because you have to move these nodes and then you have to move other nodes that are associated to it. So the software will automatically detect where that kind of connectivity might break and try to fix that for you. And in this case, it's done a very good job of that. It's moved my nodes 31 and 32 because it knows they're connected. Now you can always click here to undo that change. So we'll turn off that automated task for you. And this is probably what you would see in a lot of other programs when you go to move those nodes. You sort of get this behavior where it disconnects. So this is what would happen if I didn't have that continuous detection on. So I'll undo again and just show you another example. So I can do that through the multi-edit as well. So say I want to move this to 15 feet. So I know the exact dimensions of my roof, or the client wants something changed. It'll also detect it in that as well. So it's quite a handy feature just to help you modify your model without having to go back and recalculate a lot of node locations. Tip number 17, clicking to add area loads. So on the left menu, if I have plates open, or if I have area loads, anywhere where I'm sort of assigning a plane, once I have that menu open, the software will know that if I click nodes, it will connect them. So what this lets me do is, with my left menu open to area loads, I'm just kind of mapping out the face of my area load there. And then I can put in a pressure 0.5. And so clicking to add those area loads or plates is just a really short way to map out the face of what you're trying to identify. And just while we're on area loads, tip number 18 is using area loads to calculate the tributary area. So I've just put a pressure here. A really handy trick here is just to turn on the equivalent area loads. And this will show me that the pressure has been broken up into distributed loads by their tributary areas. So it's just automatically done that for me. It saves me a lot of time of calculating my tributary areas. It also moves. If I adjust my model, it will auto adjust. So it's a really handy way to apply loads without having to manually calculate distributed loads. And we've also got this kind of sanity check or peace of mind check here that automatically calculates the pressure that I've assigned multiplied by the area and compares that to the sum of all the distributed loads that I've applied to my members there. So that's a really great safety check. You can see there's no variance, so it's working 100% there. And it's just a really good peace of mind to make sure that that the pressure has been assigned and applied to those members correctly. And if I have more than one area load, you can go advanced, check area load variances, and this will show a list of all my area loads and whether or not they've been applied correctly. So yeah, that's a really handy feature and a much faster way to sort of apply your loads to members. So holding S and scrolling for results and loads. So if I hold the key S down and scroll my mouse, I can sort of get this sort of behavior. And it's quite handy if I just say want to turn the loads off while I'm modeling, and then turn them back on, just holding S and scrolling. And just make it, when we go to solve, it'll also work on the kind of results side too. So one of the first things I like to check when I'm reviewing results is just going displacement and using my S and scrolling, and that's going to help me identify any issues in my model. So for instance, here we can see that that's disconnected. I don't have any nodes at those locations, so you can see quite easily that that's not connected, and that's why I'm getting really concentrated deflection on those internal rafters there. So that's a really handy feature to make the most of, holding S and scrolling. And just as a side note, just introduce you to our internal optimizer that we've been building and testing. So this is a machine learning optimizer that actually runs through and tests tens of thousands of alternative models, looking for the most optimized and the most efficient model based on weight. And yeah, it's come back with some pretty great results, 42% less material. And you can see it come back pretty quickly, and you can view these results if you want to learn more about it. You can always view these and view the alternative model that we've come up with. But this is something that we're working quite hard on and also just improving on. So if you have any feedback on that, feel free to engage with that feature. But for the purposes of this webinar, we'll continue and go on to our next tip, which will be results summary. So this is kind of built into that. We kind of thought, well, there should be an easy way just to identify what's happening in my structure. Just a quick snapshot. I just want to understand whether it's fouling or what's going on. And this is where the results summary comes through, and it's identifying kind of some rule of thumb utility ratios. So here I can see it's being overstressed, it's over deflected, probably because I haven't really, maybe we'll go back and split that member and connect that correctly. So again, I'm going to use intersect members there, resolve. But you can see before it was failing, it's like, okay, I've done something wrong. I need to go back and make changes to my model, and it's actually still failing by pretty similar principles anyway. But yeah, you kind of get like a snapshot of what's happening in the model immediately. So that's just really helpful just to kind of check through and get a snapshot of what's happening in your structure. I can sort of learn more about what load combination, what member is failing. So member 34, let's have a look at that one. Turn that off. And yeah, kind of even if I want to click that member 34, it'll identify where some of those peak stresses are occurring. So yeah, that's tip number 20. Tip number 21 kind of follows a similar grain, looking at limit state results. So I'm going to go through here on the right menu and turn on my stresses, and that'll identify, obviously in the red, where the peak stresses are, where where my structure is yielding. So I've obviously picked some pretty light structures, light sections, applied a pretty large load, and that's why it's deflecting so bad or stressing so bad. And I can even isolate these. So if I've got a larger structure and I'm trying to identify just the members that are failing, I can just hit isolate, and that'll remove any of the other members and just isolate where those peak stresses are occurring. Can also use custom as well. So if I just say want to look at ones above 1000 KSI, for instance, it's just going to show those ones as highlighting red instead of by yield or by ultimate. So I've got some options there in terms of what I want to display. But yeah, that is using limit state results. Now, the final tip for today is filtering design results. So I can do this in the post-processing. So say I want to just isolate certain members, I can just click them. So that's quite handy. Or I can control highlight if I just want to look at that part of those parts of the joists. And also filter by my groups too. So I've got these columns. Maybe I just want to review my columns, see what they're doing. I want to see my beams. Again, using S and scroll to highlight. Rafters, you can see that this is obviously where a lot of the failures are occurring. and yeah, get a kind of good picture of what's happening just by filtering out and looking at these elements individually. And this extends out to design as well. So if I'm looking at sort of running a AIC design check, I can filter out my results by all sorts of categories. I can look at different groups. So I can, click these groups and just review what's happening in all of these members. Or I can filter out by, say, failed members. Let's look at all the failed members. Obviously, in this case, it's a lot. And let's look at all the past members. And so filtering is a really handy way, or clicking these tables to sort of identify the parts of the model that you want to focus on. But that's it for me. Thanks for joining. I hope you enjoyed it. I hope you uncovered some new tips and tricks, and I look forward to seeing your feedback. A lot of these features have come from the users as well. So if you have any new suggestions or ideas, we'd love to hear them, because we always want to improve and make this a better software for you to use. So feel free to send us any of your feedback, and I'll pass it back on to Trevor.
Yep. Awesome. I mean, I think even me, I'm in the software every day. It's good to be reminded about some of those really fun features that we get to take advantage of. So with that, we'll dive into some of these questions here. We got a good handful. So the first one we'll look at is, can you import/export to AutoCAD? That would be something that you can import and export a DXF file. But in terms of like a specific AutoCAD integration, that's something that we're looking into. But the actual like import or export functionality, you can take like an AutoCAD file as a DXF. Let's say you drew like the plan of it or whatever it is, and you wanted to import that as that geometry into SkyCiv Structural 3D. You could do that as a DXF file, and then reversely, you could export your geometry in SkyCiv as into a DXF file. And then just kind of along those lines, but similar, but Revit is another really great import-export avenue. And you'll get more data specifically from Revit. If you import from Revit, you get all the same section materials, or all the same section data, all the same geometry and everything like that. So hopefully that one answered that question. And yeah, feel free to keep putting them in if you have more questions. If you go to a midpoint or other spot, will member connecting to be a continuous member? I think what this person might be getting at is, I think when you're using the pen tool and you're connecting it from whatever you're connecting it to a member, does that member that you're connecting to stay continuous or not? And the member, from what I understand, is just going to stay the same. And feel free to obviously jump in, Sam, if you have any commentary on any of these questions. But the member is going to stay the same. It's just that, let's say if your member was a normal member, by our terminology, and you connected the pen tool to that normal member, when you would go to run the solve, the repair tool would recognize that, and it would say that it would recommend you to split the member up. But the continuous member wouldn't just automatically change to a normal member if you started connecting nodes to it using the pen tool or whatever else you're using. Next question: does shift node function only work for continuous members? I believe, in terms of how I imagine this question is being framed, if you have a member with nodes, obviously each member has 2 nodes to it. You can shift any member, and the member will come with the node itself, regardless if it's a continuous or normal member. The continuous versus normal designation really only comes into play with the analysis part of it, where in the analysis, it's going to recognize, continuous members will recognize nodes that are connected to it as like dump off points. Or the easiest way to picture it is if you have a girder and that girder is continuous, then it's going to recognize any beams that are framing into it. So you'll get those reactions from those beams for a normal floor loading type of scenario.
Yeah. Just on that note, so when you're shifting your nodes, it always obviously shift no matter if it's normal or continuous, but that auto detection will only connect if it's a continuous member. Because if it's normal, if you've assigned it to being normal, you will only connect to the end nodes. So if there's any internal nodes, it won't move that with it. So the detection will only happen if it's set as a continuous member, and the software by default assigns all members as continuous. So you would have had to change it to a normal member if you wanted that behavior. So yeah.
Yeah, no, that's definitely a perfect commentary on but yeah, I was trying to mention the end nodes of a member. If you try to shift either one, the member will shift with it. But like you're definitely correct. If you have, if you wanted to, let's say, shift a member that has a bunch of members connected to it and make it a slope, then yeah, you'd want that member to be continuous for those members that are connected to also shift with it. Yeah, definitely. Next question here. Is there a way to use area loads and not put loads on certain members, such as horizontal bracing, which is not load bearing? Not necessarily. I think as long as when you're loading an area load on a plane, depending on what area or what distribution type you choose, that distribution might actually occur to the horizontal, like to the bracing. But if like, I'm taking a good example, like let's say you have a frame with some X bracing there. If you do like a one-way area load against, towards that frame, the X bracing is not going to be recognized in the distribution because obviously with how the one-way distribution works is you select the direction that the distribution will go, and let's say you chose the direction vertically, then your one-way distributed load or your one-way area load would distribute to the two vertical columns on either side. And it wouldn't recognize the bracing. But if you had, let's say, an open structure load or something like that, then it would recognize the bracing. So it more depends on the actual distribution type and not so much suppressing certain members. If you wanted to suppress members for analysis, which I think is kind of getting away from the question itself, that's something else entirely. But if there's some specific scenario, you could always, just for that one frame or area wherever you're looking at, you could use distributed loads instead, and you have a little more control that way. But hopefully that answers that one. Next question is, have you made any progress for area loads for non-rectangular areas? And I'm sure Sam can help a little bit with this one, but we're always working on trying to make that feature more, stronger, because it's a very important feature for engineers. I'm pretty sure when you use, you can use a one-way area load for like a triangle shape. So let's say if you had like a triangle or even like a trapezoidal shape, it'll distribute, like let's say I'm trying to do it without actually drawing it or whatever, but it should distribute the area correctly, or the loads correctly, to a trapezoidal shape if you have the direction going with the two parallel legs, if I'm thinking about that right, Sam?
Yeah, and just because there's another related question, non-parallel plane areas as well. The one-way, it does work for one-way and two-way area loads, which I think was another question too. So a couple of questions on the area loads. But we're also working internally on something a little bit more generalized, which is basically you can capture any shape and apply distributed loads to those kind of members, and you can assign the members. It's quite a difficult kind of function to write. So it's definitely in the development stages, but it's quite a difficult one. So we are working through that. Got our kind of best guys on it, trying to add another feature that would be more generalized and allow you to do a lot more of those sort of edge cases of what you're trying to do with area loads. So yeah, stay tuned with that. I'll also bring those 3 points up I'll bring those up with the developers so that they're aware that they're 3 cases that we want to try to account for when applying area loads.
Yeah, no, that's great. And yeah, I mean, the common theme here, I think, for us is that we really want to listen to what the users want and what the users are looking for. So obviously, the more vocal you are through the live chat, through these webinars, the more we want to develop those features where we really try to exemplify a user-driven development cycle. So yeah, just staying vocal is how you see those things come into play. So we'll keep moving on. We have a few left here. Can you build a model on a sloping site? You can build really anything you want in terms of like designating a site or a specific land or whatever, something like that. That's something that would be not in the current scope of what Structural 3D allows for. So you know, if you have like sloped site and you have your columns at different elevations, or they're coming down to certain elevations, you can obviously model that, and then you can maybe put in some spring supports to simulate that sloping, whatever the soil subgrade is or whatever that is. You can try and use some vertical spring supports to account for that. But if I'm interpreting the question correctly, trying to model it specifically on a slope, or using some type of like sloping, you know, properties to the underlying, you know, land where you're putting your structure, that wouldn't be part of the SkyCiv scope for now. I don't know if you have any comments on that one, Sam, but.
No, I can add it to the feature request list. And yeah, basically, as we receive features, we kind of tally them up, and that's how we gauge what the next features will be built. So yeah, definitely add that as a feature request. So thanks for the feedback. But like Trevor said, you can definitely do it. You just got to sort of model those in through the nodes and just adjust them. Maybe using Excel, you could adjust all your nodes and just shift the structure that way. That might be a shorthand way to do it, a quick workaround.
Yeah. Yeah, and just, I mean, it kind of harkening back to the other question too, of if you have your sloped site, or your sloped building, or whatever it is, modeled in Revit or something like that, you could import from that, and you'd have all that, all those, you know, bottom node locations for your columns right at the start. And I want to make another comment too about the import-export functionality, which we talked about at the very beginning. But if you import or export, specifically when you import from a Revit file or AutoCAD file, it's not like it's all or nothing. Obviously, once you import the geometry from those files, you can take advantage of all these 22 tips and, you know, everything else that you can use in the actual Structure 3D module to, you know, continue fine-tuning or editing your model. So it's not like it's a very static import. It's, you get all the data in, and that gives you a little head start to continue modeling and applying loads to your model, and doing whatever you need to do to get to your end goal of those designs and those analyses. But all right, a couple more questions here. In order to compute equivalent load from tributary area, does the software check if the layout is one-way or two-way slab? So the software doesn't look at the members in the plane and decide for you. That's where in the actual aerial load properties, you can select whether or not you want it to distribute in a one-way fashion or a two-way fashion, or you know, is your structure open load, or, you know, is it an open structure where you only want to take into account the members tributary width itself and not necessarily the tributary area of the plane. So that would, you'd have to select that as a property. So it doesn't do it automatically like that. So, and then the last question here is, would you consider issuing PDH certificates for these sessions? We've definitely looked into it, and we're hoping to kind of ramp up these type of webinars internally for our users to really help, you know, the engineers and users we have on our platform to get better at using the software. So maybe we'll try and put an emphasis on getting some PDHs for some of these webinars, but I would say they would probably more so be external webinars that are also broadcasted to the greater industry and not just internally. So, and I think we just do one last little breeze through here, see if I missed any. Don't believe so. I think that's it. So yeah, I think that's all the questions. If there's any last minute ones, please go ahead and chuck them in there. Otherwise, here's my information. Obviously, some of you I've obviously talked to before, but I think the best way to get in touch with our support team is using the live chat. So whenever you're logged into SkyCiv at all, whether that's on the dashboard, whether you're working on a file or whatever you're working on, there should be a little live chat icon on the bottom right of your screen. Go ahead and hit that up. Toss your question in there, your comments, or whatever you need, and we'll get to you as soon as we possibly can. So I think our average response time is, I know it says a couple hours, but I think we usually get to people within 30 minutes or so. So, but yeah, I don't know if you had fun, Sam, but I had fun. The 45 minutes turned to a little bit longer than that, so we appreciate everyone who stayed on. Really glad that you guys put in all these questions. It's really great to see what the users are thinking. So Yeah, it was great.
Yeah, thanks for the feedback too, and yeah, very fun to go through it all. And if you have any other questions, feel free to email us. So thanks for joining, everyone, and have a nice rest of your afternoon over there.
Yeah, the last thing I'll mention quickly before we leave is I did see a question that I had answered originally about the webinar being recorded. Just want to reiterate that this webinar is recorded, and we'll post this on our media, and you guys should all get it in the newsletter or notification in the newsletter that it's available. So, but yeah.
Cool.
Thanks,
everyone.
Sam, and yep. Thanks, Sam. Thanks, everybody, and yeah, have a great rest of your day.
Yeah.